And just a short break there. What we're going to do now is we're going to write, well, the granddaddy of all software, innit? The Hello World program, which you need to write. It's a way of just testing your compiler, making sure you understand the very basics of getting software compiled and running on your target machine, which is the ZX Spectrum. So we'll go ahead and do that. We're going to delete this rubbish we got on the screen here. So if you haven't already done so, there's one video before this showing you exactly how to set up the environment the way I have, using VS Code and Pasmo compiler. And I've done that, and I've added this extension. Anyway, you can easily check that video out if you need to. Right now we want to write Hello World, and it's the only basic program I ever know. If we were going to write basic, you'd write 10 print Hello World, 20 go to 10. I've never actually tried to compile that using Pasmo, but I believe you can use basic code in conjunction with assembly. That's something that's a bit advanced for me. I haven't done it yet, and I don't really want to use basic. I'm told it's very slow, and I'm learning assembly language myself as a exercise of how to do assembly language and machine code, rather than using a higher level language such as basic. That would print Hello World over and over again with no spaces, no new lines, just a space between hello and world over and over again. To do the same thing in machine or in assembly language, we're going to be loading registers, and it's a fantastic book. Show you it. Don't want to show you all my files, but figure out which one is the right one. This one here. This is an absolutely fantastic book. I urge you to look that up. And I hate this PDF here I've got here, but I think this is the right one. Yeah, it's got all these icons. That's how I know it's the right one. He does an analogy where the CPU is sort of like an elf. It's like an elf, but this elf has 8 fingers. He has 16 toes on each foot. He has 8 fingers on each hand, and he has something like 6 arms, 8 arms. You'll be able to read all about it. It's really, really good, the explanation. It's quite long. This PDF is awful. Normally I can skip through pages. It's going to tell you all about hexadecimal counting. It's going to tell you how the CPU does it. I'm going to summarize it in a 2-minute nutshell, but you're going to want to read this maybe 2 or 3 times. It's a few hundred pages. Once you've read all that, like the first half of the book particularly, once you get to here, you don't need to worry so much. Once you've read that and understood it, you're going to be away. Trust me. So I'll show you the title of that again. Spectrum Machine Language for the Absolute Beginner, edited by William Tang, Melbourne House. Someone gave me that file. I'm sure it is available online if you hunt about. Let me know if you have problems finding it. So yeah. Once you've learnt about that, in a nutshell, you've got all these registers. They're pairs of 8-bit registers. AF is your main one. That's the A register is an 8-bit register, and it does all the mathematics that the processor can handle, which is basically addition and subtraction. But with the A register, you can use raw numbers with it, whereas most of the other registers you can't. You have to use a value that's already in another register. So to print onto the screen, we need to put a value into a register, like I just said. But funnily enough, the Spectrum has an inbuilt routine for printing strings, which is, you know, it's needed, especially in a computer which doesn't even have built-in graphics. So the whole thing was built around producing text on screen. And funnily enough, you don't use the A register for that. It wants some 16-bit for the inbuilt. Later on, we will be writing our code without using this routine, but this routine is highly helpful. And in order to do that, well, before we even get started on that, what we've got to do is we've got to make sure that our program will run in our Spectrum emulator without us typing load this randomize USR, because that's what you have to write otherwise. And it gets quite confusing and pointless. I never had to do that when I played my own games, you know, that I bought back in the old days. So I don't know why we have to do it when we're making our own. So the way that I've learned to get around this is create a constant. The very first thing I do, called entry point. Again, I've said this before. If you've seen my other videos, you can call that whatever you want. That's just the name of a constant, which is going to be assigned the value 32768. This semicolon means that I'm now commenting the code. Anything after that on this line will be ignored by the compiler. 32768 is the start of the empty memory. If you just think about that as your sort of blank canvas for code, there is some other areas before that, and also you can move around the existing stuff that's prior to that in memory. You could actually repoint that, but that's more advanced than I've just started touching on that myself. Don't need that to you can fit a massive game into this. Got something like on the 48k, you've got about 32k starting from there, I think, roughly. And I've mainly focused on the 48k so far. So anyway, we've got our constant there. Org is an instruction from the processor, and it tells the compiler where we're starting this memory. So we could just write org 32768, but that's why we created the constant. There we go. You also need end entry point. This allows Pasmo to compile it in such a way that it will just automatically run our code. This has to be at the very end, otherwise anything else is going to be ignored. So to open the channel, which we have to do one time, just to print to the screen, there's a ROM routine at 5633, which is hexadecimal. Let me just double check, I don't want to get it wrong before you confuse you. same thing as writing hex 1601. Exact same. That's gonna opens channel 2. Well, it doesn't open channel 2. It opens whatever channel is in A. So we load A. Channel in A. So we'll load the channel into A, which is 2. That's maybe bad wording. It doesn't load a channel in A. It loads a channel which was specified in A register. I mean, that's just the raw value 2. I don't know how to comment that. So that's that one done. That's an inbuilt ROM routine that opens the channel, and all we've had to do is feed it that input of 2. Now the next thing we want to do is make an indefinite loop so our program doesn't just close. And in order to do that, we can just literally, we could call it loop forever. I like to use a semicolon. You don't have to for a label. That's a label, and I always use a semicolon. Reason being is A, I can see it easier when I'm skimming through. B, if I go to find and I want to find the actual label, I can do loop forever with that, and it'll with the colon, and it'll find it. The reason this is helpful is because we're going to jump back to it here. Jump back to loop forever label. Here, create loop forever label. Okay, so imagine if we've got a code where we're jumping around and we've got 7 or 8 of these all dotted around in 800 lines of code or something. If you press Control F and you just write loop forever, you're going to have to cycle through 4 of them already we've got here. But of course, if you put the colon, you go straight to it. So that's the reason I put the colon. But you don't need it. It's not needed. And in loads of examples, you'll find it's not there. Another annoying thing I find on the examples, just ignore this line a sec. Imagine if I put it here instead. People don't put a colon, and then they just press tab and they start working here. So, I mean, that's all well and good. Some data. Load, HL, more data. As you can see, it's really just destroyed the look of the code. I don't know why people do it like that, but it's very common. This is the same thing, and basically to print a string you want to call 8252, which is the same as OX. I know this one off the top of my head. DAF. If you don't understand what OX DAF is, you must pause this video, go and look up hexadecimal notation. It's in that book I showed you already at the start, but obviously it's on Wikipedia and lots of other places, summarized in just a couple of paragraphs. It's not that hard to understand once you get your head around it. And the same thing goes for binary notation, base 2. So you've got base 2 binary. Base 10 is the decimal which you're always using, which is this. Base 16 is hexadecimal. And the great thing about hexadecimal is 1 byte is 250, or 0 to 255, so there's 256 different values, and that happens to be exactly 0xFF. So you know straight away the size of, you can represent a byte with just 2 letters. I'm going to comment absolutely everything on this. So, built-in ROM routine which prints string, takes inputs, DE is string data, BC is length of string in bytes. Okay, these routines are available. I've lost my link because I'm on a new profile, but the one I was using was SchoolKit, I think it was called SchoolKit. ZX Spectrum ROM routines, reference. There we go. So SchoolKit, the complete Spectrum ROM disassembly. Click everything, and here you've got a list of all the built-in ROM routines you can call. So when I call 5633, these are in hex, okay, so we've got to look up 1601, or above that. And there it is, the channel open routine. And as you can see, I'm not going to run you through the whole thing, but you can actually learn what is the input, how does this work. You can actually start calling it from here if you want, if you know what you're doing, and we're actually going to do that in a minute. We're not going to go to the very beginning of the routine for some of them. We're going to jump in halfway. So anyway, we're getting there with that. It is going to be full of, we're going to go off on tangents a lot with all of these lessons, because that's just the way it is. It's like a spider's web of knowledge we need to take in. But all you need to take from that is we're using a built-in ROM routine at that address in memory, and it takes these inputs. So we need a string data first. Well, we haven't got any, so let's make it. What should we call it? Hello string. So that's another label, but immediately after the label we're going to do db, define byte. You can define as many bytes as you want after that, and they'll just appear in order in the memory. This assigns a memory address, and that label is just for you to remember. It's pointless to the computer. To make a string you need them single quotes. You write your string, and we could just do string length db, and we could count how many bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Got 11 bytes. It's not very efficient, it's not very clever. Just saved it. So if we want to do that, we need to load DE. Really, this needs to be pointing at this. That needs to point at the memory address of the data. So that was a bit of an inaccurate note. It doesn't want the data in the register of DE. It wants to know where the data is. So to do that, you just write hello string. Putting brackets around it would have given it the data inside, but that's only 16 bits and it would have only got HE. In turn, this function, this routine, is going to iterate through a loop and get each one into probably A and print it. But for now, it's got the pointer to this memory address, which is just above that number. As soon as we hit there, bang. But we don't need to know that because DE is taking care of it as a pointer. We can load BC with, we do want the value of string length. And to be honest, I've got to check my reference here because I don't know whether we can load BC with a raw number like that. And I was trying to do this in my previous lessons, but I didn't have the internet available on stream. But what I use is Z80 Heaven. It's absolutely fantastic. And my LD, Bing's rubbish, didn't find it for me. Let's go to Google. I don't like Bing. Forgot what I'm doing now. Oh yeah, Z80 Heaven. LD. There we go. Google knows what it's doing. So this is an instruction, and it's the most common instruction. And this Z80 Heaven has every instruction that you can do with Z80. I mean, it's not geared towards Spectrum. It's actually geared towards calculators, I think, which use a very similar processor. But tell you what, I've learned one heck of a lot from this website. We can load BC with a number and all of them registered. So I was just checking. That was a bit stupid of me. I should have just carried on. So we're loading BC with the value inside there. So it's actually going to get that value and put it into BC. That's hence the brackets. And I believe this should work, although this goes against the example I was shown, because he doesn't specify the length. He does something more clever, which I will now show you afterwards. But let's make sure this compiles first. And the way we do that is we're in the wrong folder. We've defaulted to the documents folder. So the way I do it is I copy the path. CD for change directory. But you don't want the full file name path, you just want the folder path. Okay, we're in the right folder. So now, with Pasmo in the path, like explained in the last video, I'm in PowerShell. By the way, I clicked terminal, new terminal to get that when I was off air. So just in case you didn't realise that, click terminal, new terminal. I'm in PowerShell. Pasmo has been added to my environment path. When I go to that, I wrote environment path. Click that, double click that, and it's there, added. If you want to add another one, you go there. Okay. I've done this here, tap bass with 2 hyphens in front of it. That's the Pasmo compiler's options. You don't need to be an expert on these. In fact, the only one I know is tap bass. The only one I've used. I want to make sure I don't spend the whole lesson browsing internet pages. That's for you to do to get more knowledge. I'm trying to give you the rough start of how to find that knowledge for yourself, and then you go off and become much better coders than I am within a few months, hopefully. So there we go. Same as tap, but adding a basic loader before the code. So it creates a tap file, but it uses our basic instruction here to create the basic required to just run the game when someone inserts the tape. Presses load. So anyway, waffling on. After you've done that, you need the source file, which is called hello.asn, because I know I called it that, and it's right there to remind me. And there. After you've done that, write hello.tap. That's the output file. I think you can use TZX as well. I don't know what they are yet even, so I'm very new to Spectrum. Tap's fine anyway. That's compiled because we got no errors. If for argument's sake I wrote I am error. Oh, I didn't save it. I was surprised to see it compile then. There we go. Error on line 12. Unexpected I. Obviously error could be caused by hundreds of different causes. Oh, for some reason now when all my hotkeys have changed, and that went to save as, but okay, I'm saving it. Now if I list the directory, ignore h.tap, I was doing that off air. We've got our hello.asm and we've got hello.tap now. So with PowerShell open, you can do invoke item II space hello.tap, and as long as you've got an emulator installed which defaults as opening with tap, then it's going to open for you. And as you can see, it's working. I wonder whether we can leave it there. Will it reopen there next time? No, that's a bit of a pain. So I've got to drag it across every time. That's Fuse being rubbish. So we've confirmed that works, but it's pretty annoying having to count all your lengths of your string. If we change it, we've got to remember to go and change it here. It's suboptimal to say the least. So a way around that, which I've learned from a great book by Jonathan Caldwell, which is just aptly named How to Write ZX Spectrum Games. I learnt this trick, which actually opened my mind to how this works. Just learning this one trick. We've got hello string, and I've explained to death about how that's in a memory location. We can do end of hello string and declare that as a constant by using EQU, and then put a $sign, which I'm not quite sure why he uses a $sign. I think it's because it doesn't represent anything in ASCII. I tried it with 0 and it started to print the 0 of the ASCII character set, or the Spectrum character set of 0, which led to errors on the screen. well, not errors, but they were weird characters coming up. It was basically a question mark over and over again. This way, we've got some data there with an address, but there's the print command. It doesn't print anything. Like, I must admit, I don't exactly know what that means, but what we can then do is C, instead of equaling string length, can be end of string length, take away hello string. That's now the difference in bytes between the two, which is what we want. D equals DE, I'm just commenting, equals a reference to hello string memory location stroke address, i.e. not the data itself. I'm going to start a GitHub repository as well. I've got one already, but I'm going to start one purely for this series, and I'll get that done before the end of the day. So you'll be able to download this code. This should work, but let's try it. So as you can see, I'm just doing the compiler again after I've saved it. And annoyingly I have to drag it back over to you. But as you can see, it's printing hello world over and over again. There's no errors. As a quick aside, this data can be, I touched on it earlier, you can put as many bytes as you want there. That's actually a lot of bytes. It's like 12 bytes or whatever. Let me just confirm. It did print it with the exclamation mark. Yeah, it did. There we go. Yeah. So as you can see, we can now, this is a string of any length we like. Before that wouldn't have worked, obviously, yeah. But now the only thing we really want to look at is why is it running into itself. Like I said to you, you can with define byte, as long as it's on the same line, you can put as many bytes as you want. We could have also done this. And there we go. So what I'm trying to get you to take from that is, it doesn't care what this data is. It's all about how you manage that data. As long as you know that it's stored like that. And basically I could have done, these defined bytes allow you to, it's just putting the memory at that address in line. So, you could have put each line on, you could have put it all on one line or not. And we might want a new line. will do on a new line. So you can put a comma here. 13 is the code for new line. I'm just going to say that straight. I'm not going to explain it in this lesson. If you need to know right now about that, I do have some other videos on YouTube explaining it, but the microphone's a bit quiet. But you can look at I will quickly show you this one very quickly. Spectrum character set. Wikipedia is the one you want here. There you go. These are ASCII up to FF. 13 is a hexadecimal 1 1. No, 0. Oh, it's 30. My hex isn't brilliant. Let me just look it up. It's hexadecimal 13. It's 13 in it, of course. No, D. Yeah, D. So, enter. So by right, we could just do hexadecimal D, but OXD. So there should be some some new lines now being created. And there we go. So OXD is the hex version, is the hex way notation of saying 13, which is the code for pressing enter on the keyboard. Now this is strange on Spectrum. Like I've never been used to this. It's basically one big console, your terminal Spectrum. So you have to often think about it as a typewriter almost. But when you're making games, you don't actually need to worry about all these. Like, yeah, you might want to open the channel one time so you can print to it, but you're not going to use all this printing string that much. You know, it's not really a big part of your game, so don't worry too much. What you're really taking from here is how to loop, how to load registers. You're realizing that there's ROM routines built in and how to use them by loading the inputs with the data. You've learned the loops, you've learned how to create this entry point and compile it, and you're learning that variables, as I call them, are stored they're just data addresses followed by data. That's all they are. And this can be arranged in any way that you see fit. Obviously with certain limits and boundaries. Let's tidy this up. Doesn't make any sense right now. Line 1 text. OXD. Line 2 text. OXD. Line B. Line 3. OXD. Line 4 2. Wow. So I think you're getting the idea now. Taking it nice and slow. But it hasn't compiled. Oh, I didn't put a comma there. Obviously you always have to string them with commas there. And there we go. Oh, of course we didn't finish it off with a new line. So it's actually not very tidy. But there's all the sort of different ways you can lay out the data or a string. Same can be said with any values. Oh, I tried to save it in the terminal and it didn't like it. Oh, there we go. No space there. See, I've messed up again. because we would have wanted a space there, but you get the idea. So after all that, I'm going to change it back to just being hello world with a space after it, with a new line. I keep calling it a space. Compile with Pasmo. Press invoke item, and we're there. It's been a very basic lesson. I'm going to go away, get this all turn this into a GitHub repository. And the next thing, like, I'm going to take a different approach this time around, where before I jumped straight into moving sprites around on the screen, which was brilliant. People enjoyed that, but it led us straight into collision detection and inputs, which is fine, but we didn't really have an overall knowledge of how the sprites were being drawn. We were using some functions provided with lots of help. I'd even had a lot of help producing them myself. So I think what we'll do is we'll learn to create those functions first and exactly how they work, and then we'll be able to put them to better use. I mean, I have got to grips with it, and I do recommend just grabbing some code and using it sometimes if something's just too hard to figure out. For example, the Spectrum video screen memory, it really is one of the most challenging parts of it. Once you've got a sprite bigger than a character cell, you have to calculate if it's going to cross over character cells. Okay, that's all well and good, but then they have an extra hurdle, which is the screen layout of the Spectrum. So the memory of the Spectrum screen layout, which jumps down from line 0, it paints line 0, and it jumps down to line 32, and so on, and then it jumps back to line 1, and then 33. It's very, very strange. What I'm going to do is we're going to draw a pixel in order into screen memory, so that when we see it in what we would expect the order to be, we're going to see it paint it, and then we'll know what order it's actually being painted in. I think that's going to be useful. So that's what I'm going to come back to do very soon. I think we've literally wound it up here. Thank you for watching and listening. If you've got any questions, let me know. I normally answer within an hour or two, so I'm always looking out for new comments. Give me a shout. Okay, look after yourselves. See you next time. Goodbye.